So this presentation is a little bit of actually, as we talked earlier about it, it's almost a little bit of a retrospective, I guess, in a sense, but it's also more like probably more like a lessons learned. In recent months now, the YouTube tutorials, there's a series that was Python, and then there was a series that was SQL. And in the last 2 months, if you haven't been following, those sort of got combined. So it was turned into actually a tool that I had for years thought I wanted to build mostly for myself, which would be one that allows you to point essentially to two databases and do some sort of synchronization. And we'll talk about some of the issues and why that's useful and things like that as we get into this. And so that's what I'm going to talk about today. And this came out of the project's still going. The tutorials are still getting done. I'm getting close to the sort of wrapping it up or getting some of the key things done, and it'll just be cleanup and stuff like that. But it's the short of it is it's a Python application that uses that works with MySQL databases and is built to synchronize between two different servers. And so we're going to talk a little bit about that and then some of the lessons learned. And some of these are things that are, I think, useful to consider, particularly in the world where you've got a development database versus a staging or training or testing versus production, and moving things from one to another and making sure that you get all of the potential changes and differences that you need to, properly promoted up the system to production eventually. So we'll start out with a little bit about the problem definition, go a little more into that. And then we're going to talk about some of the key things that are key areas of databases, talking about tables, store procedures and functions, indexes and keys, and then data itself. Within that, there's some other things that are out there like triggers and constraints and things like that, but they more or less fall under some of the same considerations of either store procedure and functions or indexes and keys. So the application goal, the whole reason that this came about is that it is not uncommon. I think all of us have probably run into a situation where we need sort of like a shadow or mirrored database for testing or development purposes. And I say shadow versus like a replication because sometimes it's nice and we can completely replicate our production development data or production database to development. And so it's an apples to apples, 100% the same kind of comparison. In some places even do like, nightly, basically synchronizations where they just basically dump the production database and then load it into a development place somewhere. And that's not always possible. That sometimes is, but particularly when you get large databases or production data that is has some sort of requirements for people, for it to be secured and things like that. You don't want that data all over the place. It's just more stuff that you have to secure. So if you can't use the production database, there are things you can do, like you can create some test records or random data, but there is sort of a need or a use for production, we'll call it production data, because sometimes it's not useful to have, like if your users in the database are user 1, user 2, user 3, user 4, you really need to have a variation in like lengths and types. So it may be, so instead you've got like Jim Smith, and then you have Babalewski, Smith, Brown, Jones, or, with hyphenated names and things like that, that are more representative of production data that feels like, looks like what it looks like in production. And so when you combine the needs of data in particular with ongoing development, then there's a lot of other considerations, because if it's ongoing development, then there may be changes to the table definitions. You may have new columns or different types, or you may be, if you've got stuff that is using store procedures or functions, there may be steady changes to that code. There may be relationships and indexes and things like that that are built as part of your development efforts, and those things need to be changed or like promoted up, or sometimes you want them rolled back because you want to be able to say, I'm testing something or validating something and it works fine in my development environment, but it doesn't when it's in production. And so I want a way to sort of, pull pieces of production and use that to create a valid test environment. And it's not trivial. Like I said, these databases can be huge. They can be very complex. And sometimes size alone is just too much. If you've got terabytes of data, doing a nightly restore down to the development machine can just be way too time consuming and require a lot of resources that you don't have. It's like you may not have enough of a development resources to have a multi-terabyte database as part of what you have there. So dumps and refreshes are useful and sometimes are exactly what you need. And in a lot of cases, that's sort of what we work with, but they're not always feasible. We also have situations where we don't have a way to spin up a development environment. You basically have to point to the production database because they don't have scripts, they don't have history, they don't have anything for you to create a small database, a clean or a fresh database. All they have is you just pull the whole thing down. That stuff can be really time consuming and annoying. And then, it's just general, like if you didn't create and maintain and use proper processes building your database, then creating a fresh or copy of that version can be very difficult. And that's part of what, all of that is what sort of falls under the goals of this application, some of the problems that we want to solve. So let's start at the table level. Some of the things we have to think about if we want to match up tables from one environment to another. And it's really, if you think through it, it for the most part is fairly logical and commonsensical. You have to worry about columns. You want to worry about whether you have new columns. So I started with 3 feet, like I had let's say an address in production and realized that I needed to add somewhere along the way. We were like, oh, let's add state or let's add country. And I didn't get that, percolated down to all of my development areas because it was something that was a hot fix, or like, Michael's working on it and he pushed all that up, but my local dev database, I didn't get that picked up. And maybe we don't have quite the SQL, version control for me to be able to see that. So I need a way to know, hey, there's a new column. And this could include not only like a new column, but then changes to existing ones. So the address column goes from 40 characters to 80 characters. I need to know that. Or maybe we went from, more complicated. Maybe we went from address type was a 4-letter character field, and now it's been turned into an integer that's actually an ID lookup into another table, and that sort of gets into indexes and foreign keys. Maybe there's some performance tuning stuff that was done. So we had to create a couple indexes to help, utilize help with performance tuning. And there may be foreign keys, for example, maybe we were normalizing stuff. So we had some data and we looked at it and there was really only 3 values that were there, but they were big and clunky to record. So instead we said, hey, let's just pull that out to a lookup table, a little foreign key reference that says, each of those now is just a number in there instead of, some big long string. And then the interesting one that becomes a challenge, one of those things that you almost have to punt on would be like column name changes. Because if I change a column from address to address 1, you can, because basically what's going to happen is you're probably going to look at it and say, oh, column address got deleted and address 1 got inserted. From a logic point of view, you may need to know that address is address 1, or address 1 is what address used to be. From a synchronization point of view, then there is really no such thing as a change. Every change in that case would be from a column name, because that's the only way that you can identify a column is by name. because otherwise it could be, the same type and size and all that could be two completely different columns. So in that case, you would need to understand that a change is really, it's a delete and an add as opposed to a direct change. So you're normally, basically that leads to, with tables, it is really three things. There is deletes. So this column doesn't exist or should not exist in my local table. There's adds. This column doesn't exist in my local table and it should. And the other thing is changes, which would be the column with this name exists in my table, but it has mismatch. It has a different type or size or constraints or default values. So I need to deal with that. Procedures and functions are a little more complicated, a little in some ways more complicated and some less. Procedures and functions typically, particularly in this case, we're talking about MySQL, the name and the owner are unique for the schema. So, and that would be things like, so I've got a function that is part of a schema, and by owner, I mean, really it's the schema. So if I've got my developer schema, I could have a add one function that is the developer add one, but then I could also have Melosh Consulting database, and it could have an add one. And those are two different store procedures or functions. So that's sort of how our how we match from one to another within a within a database server within schemas. And then when you're looking at differences from your source to your target, one of the things is sort of obvious, I think, is the signature. You may have if it's a different function name or a different store procedure name, then it's the same thing we ran into with columns in a table. It's not really, you didn't change the name, you dropped one and you created one with this different name. So there's no, you don't have to, in the synchronization, link the prior and the current names. But the signatures can change. So that add one procedure I mentioned, maybe initially it had one variable, and then later I have two variables. Maybe now instead of a return, there's an out value, out variable. Maybe the type changed. So instead of bringing in a varchar, I'm bringing in an integer. And sizes, instead of 4 characters, now it's been opened up to 10 characters. So the signature can change significantly. Likewise is your returns. Like, for example, particularly for a function, is that the value and the type may be different. So you may have a different, maybe before it was an integer and then you realize, oh, wait, it needs to be a float, or something like that. And then, of course, there's the source code itself that can change, actually what that function or procedures does. And then there's permissions that really applies to all of things that could be tables and everything else. But it's like who owns it, who can run it, who can delete it, insert it, update it, things of that nature. So these are all considerations you need to think about when you're syncing these things up. Now, for simplicity, the nice thing is that most of what we need to do is not really so much a compare, other than when you get into like signatures and data types and values, because those may be the same name. And there's a little, and it's just basically, I guess, and even then you don't have to necessarily compare it, because what you could do is just say, all right, I'm going to, if there's any difference, which I guess would be a compare, if there's any difference, then I'm just going to take the source definition of it and make that the target definition.